Well, hi, good morning. Thanks so much for joining me here in my shop. I'm going to be doing more alignment work on the radio you see on my bench. And so I did the IF alignment on the last video. Seemed to go okay. Now I want to do the RF alignment steps with this radio. This one's a little more complicated than the last. The last one I worked on. So I already have some equipment connected, so I'm going to run over what I'm doing here, double checking what I'm doing in fact, before I go ahead and do it. So let's start out with the connections in the radio here. So I have this connection, which is the sweep generator output. Oh, it's going nowhere. Okay, I haven't figured out where to put this just yet. What we're trying to do here is take a look. You know what? We got to go on the schematic to do this. Okay, let me put the schematic up, and then I can make some sense of this whole thing here. Okay, so we're really interested in tuning up this front end, and that amounts to adjusting this trimmer, this slug, and this trimmer, and this trimmer. This one's kind of special. This is a local oscillator. So, but right at the moment I'm trying to set up to go through the front end here. So, so I want to for instance, examine the resonance of this part only first. So this is the antenna. That's pretty easy for me to couple a signal into an antenna. That's what it's there for. And I can look on the plate circuit here, the scope. I can have the sweep coupled into this coil, into the antenna. And that should give me a look at the response curve for this part of the radio, right here, nothing more than this. So that's what I'm trying to set up for. So where should I put the antenna? No wonder it's not connected. I need to couple it in with a coil. Okay, let's get that going. Couple in this with a coil. I'm going to guess a very small coil will do the trick. We can put a bigger one on if we think it's necessary in the end. This is just a clip lead. I'm going to hang this right over here where the antenna is. Clip it right on there. You can see the antenna coil right here. That should couple in pretty good. So I already have the sweep set up here to be sweeping, let's check it, from 450 kilohertz. That's not a good idea. To 750 kilohertz. So I was trying to get 150 kilohertz either side of 600. I decided to work on the radio at 600, just like I did the last one. The problem is 450 is right down in the IF range. That's too low. So why don't I reset this? I'll have it go from 500 to 700 with 600 in the middle. Okay, so we'll do the start frequency here then should be 500. Okay, and then the stop frequency should be 700. Okie doke. Output level is low, which is good to start, but it's just going into a coil. Now, one of the things we want to find out is the location of the frequency of the local oscillator. So to do that, this is my SDR antenna input here, and if you follow this back, it goes to this guy. Yeah, that's not much of an antenna, right? That looks more like a scope clip, but I use these things sometimes to provide inputs for the radio. Now all I'm doing is taking the end of it here, it's not even exposed, and just shoving it inside the oscillator coil. That will probably induce enough signal capacitively, or however it's doing it, into this lead that'll show up on my SDR radio. We can look at it, spot the local oscillator, and then adjust the radio to force the local oscillator where we want it. The weakness in this whole setup is I have no idea if this pointer's in the right spot on the string. Now the dial is in the radio. I'm looking at it right now to see if there's any hints as to positioning the pointer, and there doesn't seem to be any hints. Now there's a back plate for the pointer. I had to remove it because the back plate covers some of the trimmer adjustments. There's the back plate. There's nothing going on there. There's no special marks of any sort to hint at, you know, like close the capacitor all the way and make sure the pointer is pointing at this little test mark. But there is no test mark. There's no instructions I found in the information I have on the radio. So we'll go on the basis that the pointer position is the last thing that will be adjusted. Wait a minute, is that glued in there? Is that pointer glued onto that? Yes, it has actually. So in the manufacturing of this radio, when they put the pointer on the string, they then dabbed it with glue. So okay, I'm not going to move it. Wherever it ends up in the end, but at least the radio will be performing well, even if the pointer's not pointing at exactly the right spot. That's what we're going to do here. So I've got signal input onto the antenna, scope watching the output of the first tube, and then I've got the ability to examine the frequency of the local oscillator. I think we're good to go here. I think that's it. I think that's ready. There we go. First time powering up today. Oh, there's that. There's that clock motor again. That always kind of scares me a little bit. I'll turn the sweep on. Oh, we're not hearing much of the sweep. Now, maybe the radio's not tuned within the range of the sweep. Tune over that. I don't have enough power coming out of the sweep generator, so I'm going to increase the power quite a bit. Oh, and there we are. So we're going to tune this now across the range of the sweep, which is just sweeping up here. Whoop, not with that, we're not. There. So I'm outside the range of the... Oh! Hey, what's going on there? Probably mistaken. So this is outside the range of the sweep. The sweep ends at 700. So that's probably 700 right there. That's interesting. Now I would have expected that to be kind of consistent in the sound right across as I tuned it. So I think what's happening is there are other signals being picked up, I think. I don't get it. Seems that way, doesn't it? It's like other signals are coming along and activating the AVC, which is reducing the sensitivity of the radio, and the tone we're listening to is disappearing. That suggests to me the tone is the sweep is barely getting into the radio. So let's go to one of those spots right here. I'm going to increase the sweep. Oh yeah, so it's just easy to overcome it. So that's all that is. Just very, very light signal, AVC, not activated, radio very sensitive, come across a noise signal, AVC quiets the radio, and we lose the sound of the sweep. That's all that is. Everything's working great. So now we want to get this to 600 for sure, and I'm going to have to look on the SDR and try to spot the local oscillator. Okay. This is probably the local oscillator right here. If we are at 600, then this would be at 1055. So we're not quite at 1055. So I'll tune the radio, and that'll push the local oscillator over to this frequency, 1055. Okay, so I'm going to tune the radio here. A lot of backlash in this tuning, a lot. Not very good. Okay, well that's pretty darn close there. There we are. So now I have the local oscillator set at 1055 kilohertz. Let me turn down the volume here, we don't need to hear it. That's interesting. What's happening there? Let's go back and look at the radio now. Okay, so the radio is set to receive 600 kilohertz signals. The sweeper is sweeping by, and let me just double check now to make absolutely sure of this, because it tends to vary a bit. Starting at 500, finishing at 700, just a touch low, 700. So now we look on the scope. So now we know the scope is sweeping such that right in the middle is 600. The radio's tuned to 600, and in my imagining it, there's a little tiny blip there. But let's turn up the input there. So I've increased the input signal. Well, it's bang on. So this I believe is the response of the front end of the radio. It's right on the money. Wow. Okay. Now I thought I accidentally tuned this off. So I'm going to make a little video change here. I'm going to stop for a minute, rearrange things a bit, and then we're going to carry on. Okay, so the objective here is to verify that the coil I think we're looking at is the one that we're seeing the response curve for. By the way, even though this signal generator is running, it's not plugged into anything. It's just waiting in case I need it. Okay, so coil is way down here. I think I've grabbed the wrong tool here. I don't want to do it with this. Do it with this guy. Not sure I can get all the way up there from the bottom here. Let's give it a try. Wow. It's a little uncomfortable. Let me try from the top here. Okay. Everything's still working. So when I turn this, what I'm expecting is to see that response bump move. Didn't move, but it's definitely changing size. So why would I think it's going to move? Well, why would it move? It shouldn't move. It shouldn't move. Yeah, it can move because I'm looking at a sweep. Sure, it can move. I vary the resonant point of the very front end of the radio. That thing should move left and right. Okay, let me turn it some more and see what's happening here. Well, it's definitely not moving anywhere. Okay, back down. Now I had it down like this. Oh, there's another peak coming up. Uh-oh, not good, not a good thing. Okay, let's go back. Down and back up. Well, that's kind of interesting now. Have I got this thing all backwards, where in fact I should be trying to minimize this? That doesn't make sense. What could I be getting wrong that would make this work backwards? Completely backwards. That's a curious thing too. When I turn the volume down, the trebly part of the sound goes down, but the bass part stays. Okay, too many problems all at once. So I'm getting a behavior here that doesn't make sense to me. Let's look at the schematic. Maybe I can confuse the situation even more here. Yes, I can confuse it more. So what I've got going here, we're looking on the scope right here. Of course, this circuit is resonant here. You know, we're probably looking at this resonance. It won't matter how much I adjust. Oh my gosh, I'm adjusting the slug on this. I'm making a total mistake. I'm doing the totally in the wrong thing. I'm supposed to be adjusting this. Duh. Okay, that explains it all. So I have to find, well, this is probably the first of the three sections of the capacitor. Oh, trimmer. Okay, that explains it. Okay, little mistakes being made. Now there's three sections on this capacitor here. So the one in here is the smallest. That's the oscillator. You got to kind of guess it. It goes first, second oscillator. Okay, maybe I can even do it with this. I doubt it. Stiffer, bigger screwdriver. Okay, now watching the scope. Does this make any difference? See, what about this one? Nope. Okay, now I turn this. What happens? There we are. Now we're moving. Now we're talking. So this is locked pretty tight here, but there is a bit of room, and you could go way out to here. It's bigger out there. It gets smaller. You get it right on the mark. I think maybe I need an indicating meter going on the ABC voltage at the same time I'm doing this. Because it seems like this is a better spot. See, I could back this out a bit. Then I can push the local oscillator back. Does this make sense? Oops, shorted something out there momentarily. If I change the local oscillator frequency, I'm going to have to retune the radio to get it back to 600. And that's going to move. Wow, that's interesting. So if I have the radio tuned now, the front end tuned in a more preferable spot, simply because I've got it in the range of this capacitor, then I could tune this and put this back on 600. And then you have to adjust the local oscillator now to get the 600, because it's probably not 600. Okay, back to the SDR here. You can see the local oscillator has moved off the 600 line, or the 1055 line in fact. So I'm going to use the local oscillator to move it back. Oh, a little short there. So that appears to me to be right on 1055. Now, how do we know that this my SDR is accurate? We need to check that before we go any further. So I see the shift is set to 40 hertz over here, right over here. Well, let's go quickly to 640, which is roughly here. Ooh. 640. Good luck on hearing us. We're going to try to hear our radio station here. Next to no antenna. So, okay, now we got everything on the screen here. So we have the local oscillator running. Oh, that's right. I'm verifying the 640. So the SDR is tuned to 640. Here, give it an antenna, me. Can't say I heard any 640 there. Yeah, we'll try to 590. It's a stronger station there. Okay, I step in as antenna. So it's there. I need a better fake antenna here. What about this? What about something real? What about a real antenna? What about a real antenna here? Okay, that's good enough. Now we're going to tune this. Alright, I have to band spread this out. So that looks to me to be dead on the signal right here. Right on 590. Good. So that's calibrates this. No, we want to be looking at the local oscillator all the time. So we take this back down. Local oscillator should be somewhere around. Oh, okay, hold on. Disconnect that. Put this back in where I'm picking up the local oscillator signal. There it is. Yellow line. Verify it's still at 1055, which it must be. 1055, right on the money. Okay, so everything is set properly. And so, okay, turn our attention back to the front end of the radio. Well, it looks really, really good to me. I'm going to double check the start and finish frequencies here. We're starting at, I have to make this very accurate, 500 now, and stopping at, both dropped low a little bit. Stopping at 700, sweeping. I mean, can I get it any more accurate there? I don't think so. Yeah, that throws it off entirely. Can't rely on it. This is good. Okay, So the impression I have now is the front end of the radio is properly tuned to the same, to be sensitive at the same frequency as the local oscillator is operating. Good. That's the very front end. Now the next thing is a coil. There's a coil after this. I can turn it down this way. Let's take a look at the schematic and figure out how we're going to get at the coil, get the coil picture going. I think it's pretty straightforward, actually. I'll just leave that up there like that. So we've done this part. Now we want to do this part. So if I hook on anywhere here, I'm going to disturb it. So I'm going to go on the plate here. This is not the best place to go. But that's where I'm going to go. I'm going to put on the plate of the converter to pin 5. And the input signal can continue on the antenna here. I'm not worried about that. It's the same signal. Even if this stuff's mistuned, it's the same signal coming through only weak. It's not mistuned anymore. Okay, so pin 5. We just simply moved the scope to pin 5. That's all that amounts to of the 12BE6. Okay. So now we're going to unhook the scope. Okay, not a big screen for my camera anymore. Now, scope unhooked, and we want to connect it to the plate, which is pin 5 of the 12BE6. Now let me just, because I don't want to be dumb, 12BE6, yes. I don't want to be dumb. 12BE6, pin number 5. Counting here. Let's see. 1, 2, 3, 4. Here's pin 5. Big strong signal. Wrong control gem. There we are. We got another peak sitting right in the middle. Looks like a glass thing. Now this is conceivably 2 peaks coming through here. Peak from the first thing I did, and now additionally peak of the second coil. So we had the 2 of them together. Is that the best idea? Is that really the best idea? Can I move the injection point forward? Let's try this. So this is I flung this coil wildly there the other day by accident. Okay, we're in. Now, watching the coil there. Ooh, don't move. I really hate having my finger on the chassis like this. So you see it bobbing up and down. That's a DC variation in the signal here. So So I'm sweeping from 500 to 700, and we think we're looking at 600. It's really tight. I can actually expand it this way, but it shoves it off to the side. So kind of recenter it again. Yeah, I can get the whole thing on. That's good, actually. Well, I mean, how much better can I get it here? This one shouldn't change the frequency, I don't think. So again, the variation. Oh. Okay, so Hawkeye. If you have a Hawkeye, and you look here, you can see a little whirly thing. That's the actual coil tuning. You can see it up here too. Now watch. I'm going to turn it. Watch that little thing move. Did you see it? So I think the bump. Oh, where am I pointing here? I think the bump is right here now. The bump that I'm adjusting, and it's going to come right on top of the other bump. Right there. And now it's off to the right. You can see it coming out. So if I get it right on top, it would be about like this. So it is moving some frequency, some resonance. Anyway, so I think that's that. So that's the first, the coil. What's that coil resonant against? It's not against the other tuning capacitor, is it? Okay, good. I got the schematic right here. Fantastic. So what is this thing? So this coil I'm adjusting is against this capacitor and its trimmer. So that's kind of curious, because this has got to be affecting the coil in a similar, or the resonance point in a similar way. Well, I should make sure this capacitor is kind of in the middle and not push to one edge. So let me check on that. So there's been a number of radios that I've done, and now in retrospect I realize I could have done a little more, where the trimmer capacitors are clamped down all the way or turned out all the way, and I think I realize I've been kind of short-sighted on how to deal with that. So first we're checking the position of this trimmer. Okay, so it was almost closed all the way, in a sense. So I'm going to back it up. You know what happened on the screen there? Anything happened? What happened? Okay, so I'm going to back it up. Now that should have moved the tuning point a little bit to the right. It seems to have done that. It seems like this is moved off the center line slightly. But the capacitor, but when I do the coil, it should bring it all back. Really? Is that really what's going to happen here? I don't know. Okay, cleaning the coil. Okay, is that centered on the scope? That's about center. Wow, I mean, it's really pretty darn close. And then let me check the sweep again. Starting at just a hair low. Okay, and stopping at just a hair low again. There we are. Sweep. Right on the money. I think that's got it. So I have so I should make another. There's a local oscillator in the deal here. Where is the local oscillator? Local oscillator is way off of 10. Oh, I don't have the thing. Hang on here. Okay, so it's right on the money still. So local oscillator still at 1055. I've got this other speaker on here. don't need to hear that. Local oscillator at 1055. Radio's tuning at what I'm sure is 600. So I can adjust this a little bit, but I shouldn't need to. That's it. I don't think there's any more I can do here. Unfortunately, until I put the radio back in, we really can't check the pointer against the dial front. But the objective here is actually to achieve the highest performance. There's no reason why you couldn't force this all into the to match the dial too, if we could. So I'm going to straighten out my. This is the most dangerous maneuver I have to do on this radio, is straightening out the pointer here, which is bent downwards. Accidentally bent this. Okay, good. You only bend those things, so many times before they break off. Time for a test on this radio. Let's see how it's working. Okay, cut this guy off and remove it. Pull out the SDR. Pull out the scope here, which may increase the radio's operation. Get that off there. There we go. Okay, so all this is now is the radio itself. So we think we're at 600. We can actually figure out where we are. Let's go towards 590. Now this antenna may not be in the right orientation here at all. Let's go back to 590. Right.
Although I'd love to hear more about your thoughts on Steve in the shower, where I find. I thought the next week
Tone. Volume.
I can't remember the last time I took a bath. I don't know if it's been a decade. Yeah, it's been at least a decade.
Okay, here we go.
Like, who doesn't like to lie in their own filth in a bath? Really, it's really fun. Especially in a hot summer.
Here we go now. 610? Don't think so. 640. Pretty sure that's 640. 680. Wow. Oh. That's something. I didn't realize how. Wow. So I think what's happening there is that at this point I'm nulling out the noise signal. The loop antennas have a broad receptive direction and the null is very, very sharp. So you steer the null, you can null out interferences. And I think that's what's happening here. Wow. Okay, keep that in mind. We'll go up. Let's see, after 680 it's tough to pick up anything. Okay, we'll see what happens. Here's the French station. Oh, that's good.
Merci à vous, bonne journée.
Bonne journée. So from here on, most radios in my shop, at least the ones I work on, don't pick up anything. Let's see what this one can do. Don't pick up anything during the day.
Sounds like you really love your truck. Yeah. Yeah, the Ford F-150. Just love the biggest award for lowest cost to own in this class. Now during the 4th year of the decade.
Volume?
500 in rebates on select new 2019 F-150.
Lots of volume. Okay, he's back in the cabinet once again. Boy, I've had this radio in and out of this cabinet 5, 6, 7 times in the last couple of days. So let's give it a try. Switch it on. See if we can see some light coming out of it here. Hey, where's the light? Oh, it's in there. You can't see it. Wow, it's really, really dull. Okay, you can see it over there. But we'll do it this way. Okay, Mr. Radio. Tune a bit.
So you can spend less time worrying about life and more time living it. Right now, with the class coming up in your area, this class is where we've got thousands just like you, our patented core strategy designed to teach you how to make better investing decisions. In just a second, you'll be able to register for one of these free classes, so get your phones ready, and if you're driving, now's a good time to pull over. Included with your passes is going to be our Professional Insiders Kit, and this kit is packed with important information from some of our top instructors. Introducing topics like enhancing retirement strategies, opportunities when the market goes down, diversifying income streams, and much, much more. The Professional Insider Kit makes it so you can start learning right now. Call now to... Rotary phones. You know the rotary phones are worth, I just sold a phone, a red one, $72.
So if you're wondering what the heck I'm doing, this loop, a simple loop here, is hooked up to an outdoor antenna. And so there's some signal from outdoors on this loop, and I'm just holding it up to the radio antenna, and sure enough, it's helping out. Kind of interesting. Never tried that before. Another way to couple my outdoor antenna to
They can't see it doing much. Right. This is a lifetime of stuff that collects. And they don't realize you can take all this stuff out. You can have the house ready room.
Une infirmière, etc. C'est ça la réalité.
Oui, c'est ça. Puis, ce qu'on remarque, en fait, c'est ça, c'est que le réseau s'est un peu délaissé sa responsabilité de répondre aux besoins des Autochtones en santé. Et ce qui se passe, c'est que là, on finance justement à la pièce des initiatives locales, qui sont des initiatives très dynamiques, qui sont des initiatives qui sont porteuses.
So holding the loop up there detunes the antenna, but compensating for that is the strength of the reception in there. So it's actually having two effects, right? It's driving down the resonance of the front end of the radio, but supplying a strong signal. I'm going to try the same thing now off my loop antenna. We'll see if this is a good station to do it with. Now, there's no way to hook up an external antenna to this radio. There's no terminals produced at the back or wire hanging out or anything. So we'll put this on here. It's a loop to a loop. Okay, I'm going to hang it back here. So if anything, it detuned it a bit. I'm going to tune the this antenna here. No effect yet?
Puis c'est ça, puis ça dépasse les questions aussi relationnelles où on dit, ben oui, effectivement, il y a des préjugés qui sont véhiculés dans le système de santé, il y a des professionnels qui véhiculent eux-mêmes ces préjugés-là, effectivement, mais au-delà de ça, on a aussi toute une organisation de soins qui est là et qui n'a jamais vraiment tenu compte de quels sont les besoins, quelle est la vision de santé des Autochtones, puis comment on peut répondre à ces besoins-là.
I hear one of those tones. I hear a heterodyne tone. Is that from an interfering adjacent signal, or is that from something happening with an image signal? If I tune the radio and the pitch doesn't change, then we know it's just an adjacent signal.
Oui, absolument. Même en promotion de la santé, je dirais, regardez les
and the pitch doesn't change. It's always the same tone, so just an adjacent noise signal of some sort. But I'm pretty happy about this. Impressive. Why couldn't I put some kind of amplifier? It boosts the signal into this coil. I just have this coil sitting here in my shop, just basically replaying what's outside. Relaying. Probably no reason why I couldn't do that. It's another interesting area to fool around with. So, the end result, another improvement in alignment. So I think, the lesson here that I'm learning is the instructions you come across in the vintage documentation for radios like this are written for that time. And at that time, nobody had a computer, nobody had an SDR radio, nobody had a frequency spectrum display to look at. Guys in shops they'd be lucky if they had this much equipment that I've got. But even with all this equipment, without a few little tricks, just following the instructions in the manual, it looks like I cannot hit the mark. Now, maybe I'm lousy at following those instructions, but it looks like taking this extra effort pays off significantly. So I'm pretty happy about all that. And okay, I think it's time for another radio. I'm a little tired of seeing this one. So thanks a lot for watching the videos I've been posting. And I'm going to select another radio to work on. Great. Thanks a lot for watching. See you on the next radio. So apparently taking this radio apart 12 times is just not enough. I'll have to do number 13. But anyway, thanks a lot for watching. I won't bother videoing me. So stick that bottom plate back on. So thanks a lot for watching, and I'm off to find another radio to bring in here.